Hello, I'm Steve Waterworth, Technical Marketing Manager at Weaveworks. In this video, I'm going to show you Weave GitOps Progressive Delivery, deploying new features and fixes into production safely. Weave GitOps is a continuous operations product that makes it easy to deploy and manage Kubernetes clusters and applications at scale in any environment. Built on Flux, it provides continuous application delivery while enhancing security and accelerating software delivery lifecycle. We all know the best way to break any software component is to deploy it into production. Using progressive delivery provides an approach to mitigate this risk. Rather than taking a big bang approach, initially only a small percentage of traffic is exposed to the new release. Service level objective analysis is used to inform the decision whether to continue the deployment incrementally, shifting more traffic to the new release, or rolling back to the previous release if the service levels are not met. In the event of a failed release, only a small number of customers will have been affected, with only a small potential impact on revenue. Many DevOps teams are reluctant to implement progressive delivery due to the perceived extra complexity. Weave GitOps Progressive Delivery, built on Flagger, is fully automated and configured with just one simple file, managed by GitOps, of course. Metrics for service level objective analysis can be queried from observability tools such as Prometheus, Datadog, and New Relic. Notification of deployment promotion or rollback can be sent via Slack or MS Teams, as well as being shown in real time on the dashboard.
Here is the Weave GitOps Enterprise interface. We're looking at our multi-cluster control plane where we can see all of the clusters within our environment. Today we'll be focusing on this Progress Delivery Demo 32 cluster. This is a liquid metal cluster we created from bare metal, and we bootstrapped several processes and applications onto that at cluster creation time. If I drill into the applications, you can see that I have Flux and Flagger installed. If I drill further into Flagger, we'll be able to see all of the components that comprise that Flagger installation. We've installed the base application, a load tester in order to generate HTTP traffic, and the Prometheus plugin to use Prometheus for gathering metrics and for analysis. We've also installed a pod info application, and that is running on this cluster successfully. We can see all of the objects that comprise that application, and the current image version is 6.02. If I prefer to view this in a graphical view, I can do that using this section here. You'll notice that all of the various components are all green, which means that they are running and that the Flux agent has successfully reconciled those. I'll flip over to this tab here, and you can see the GUI for my pod info application. You can see that it's running version 6.02 and is in a healthy status. Over on my demo repo, you'll be able to see how I've configured this Canary rollout. Let's drill into the main demo repo in the applications pod info templates. You'll see that I have a canary.yaml file here where we've defined our Canary release. So this is a kind of Canary and then the various configuration steps to create that. You'll notice that I'm referencing my pod info application, and I'm going to set up a test window here that my rollout is going to progress over a time span of 60 seconds. We're just doing this for demo purposes. In your environment, you might want a change or outage window of several hours, maybe on a weekend. You can see here that I'm going to be conducting analysis every 10 seconds, and I am going to only allow a maximum of 10 failed tests before I'm going to automatically roll back this update. I'm going to increment my tests by 5% until I reach 50% of the traffic going to the new Canary. And at that point, I will roll it over as the primary permanently. My test metrics are configured here. I'm going to be using a request success rate, and I'm going to require greater than 99%. So I'm going to want all of my web URL traffic to my application to be successful in order to consider it a successful rollout. The actual test I'm doing is this curl command here, and I'm going to connect to my Canary and I'm going to fetch a token. If I fetch that token from my application, I'm going to consider that a success. All of this metrics and this test can be configured for your application specifically. We're just using pod info as a simple example here. In the Weave GitOps Enterprise Delivery section, I'll be able to see the status of that Canary. So this right here is showing me my pod info application and the status and message from my last run. You can see that this last rollout was a success, so it promoted it to be into the production system. I can see all of the objects here, and you can see that my Canary deployment is spun down. It was at version 6.02, and it has been moved over to my primary now. So version 6.02 is running. I can click through and see that image URL here. Okay, I think we're ready to run this Canary. So I'm going to go back into my repo. I'm going to go to my cluster, which is this progress delivery demo 32. I'm going to go into the application section, and I'm going to modify this podinfo.yaml. In this case, you can see this is a very simple deployment, and it's running version 6.02. I have rights to edit this file, so I'm going to change this to a different image that I know is going to generate a failure. I'm going to do this so we can simulate what happens when a developer puts some code into the system that is not going to work. Because this is Git, I'm going to comment my change here, and I'm going to say deploy potentially unstable version. And now I have the ability to commit this change. I could create another branch or create a pull request. Now that change is committed, you'll be able to see within about a minute that the status of this Canary deployment in the delivery section will start to detect that that change has taken place, and will start commencing my Canary rollout given those rules we defined within Flagger. So I'm going to start monitoring the objects here, and you can see that it detected a new image version there. I should receive an event that there is a new revision detected, so it's going to start scaling up my podinfo.test. You notice I'm on step 0 of 10, a new revision detected. So I am going to just, as an application administrator, I'm going to watch this delivery section and see that my Canary rollout is progressing. In this case, it's performing the analysis here, this request success rate. And if I wanted to check the actual command being used, here's the kubectl command I'm using to gather this information to present in the GUI here. So we'll just watch this, and we notice that the failed checks are going up. I'm also monitoring my application here, and I notice that even though I've put in a change to have this upgraded, it's still running perfectly fine at the old version. As this progresses, I can keep an eye on the Objects tab, and I can see that my primary here is still running the 6.02 version, even though I have requested this new errored version to be there. We'll continue to watch this until it reaches the 10 errors, the 10 failures that we requested, and continue to watch the events coming through. We notice that the current success rate is at 0%, which is less than the 99% we required. So it is going to halt the process of this upgrade. This GUI provides a nice, easy self-service model for application developers and platform teams to be able to see the health and status of their application. we can note that at any time, the existing application continues to run perfectly fine. And we can see that now that we have reached those 10 failures, our Canary deployment has failed completely. I get a message that it's failed, and the deployment has now been scaled to 0. And we can see that happen in real time. So the replica count of my deployment is now at 0, but my old production version is still running, and my application is still available. I could refresh this just to make sure that we're still up and running. So you can see that Weave GitOps Enterprise has protected my production application despite an error in my deployment. Now let's go in and see the history of this file. Because everything is within Git, I get a definitive list of all changes that have been made to this file, so I can evaluate which developer has pushed which change and whether it was successful or not. In this case, I can look at this commit details and see the changes that were put in. I can then revert that change automatically, or I can do it myself manually if I want to do an upgrade to a different version. That's what I'm going to do. I want to show you upgrading from version 6.02 to 6.03. So I'm just going to go back and edit this file. I'm going to change from my podinfo.error to a known good version. .6.0.3. And then I'm going to commit upgrade to known good version 6.0.3. And I'm going to commit those changes. I'm going to flip back to my application to confirm I'm at 6.02 today. And then I'm going to go back to the delivery section where I'm going to see that previously failed deployment. And I'm going to watch in the details as the new version is detected, the change is detected, and I'm going to watch it now successfully be able to roll out that 6.0.3 upgrade. I can watch the Events tab, and within a minute, that Flux agent is going to pick up that change, and it's going to commence my Canary style rollout. There we go. So we can see that a new revision was detected again. So I'm going to progress with that Canary analysis. So again, I'm going to rely on that same request success rate, greater than 99%. I'm going to monitor the events to see that that new revision was detected. It's going to scale up my new podinfo.test. You can see right here, we now have one replica running on 6.03. The old version running on 6.02 will be running until the testing has completed. I can follow along the details here, and I can see I'm now at step 2 of 10. I have a Canary weight of 10 currently. I'm going to get to 50% before I'm going to roll that into production. You can see that my rollout is progressing just fine here. The one failed check is just that initial test when I'm spinning up my podinfo.test, but all of the traffic going to the new version are working just fine. So the load tester within Flagger is connecting to this new 6.03 version and checking for success, and then ramping up the amount of traffic that's hitting that new pod versus the old version. Once we reach 50%, it's then going to move over everything, and I'll be upgraded to my version 6.03 as my primary. You can see every 10 seconds, it's going to ramp up that Canary weight. And now we are at 50%. So we'll monitor the objects, and we'll start to see that now that we've reached our 50%, the Canary analysis is completed, So we're going to start the primary rolling update. So you should see the 6.03 version will now be moved into my pod info primary. There we go. Our primary is now at 6.03. When I flip over to the application GUI, I notice that it has been upgraded successfully to 6.03. Once that is complete, it's now going to ramp down my test to 0 replicas, and my Canary rollout has succeeded successfully here. My application has been upgraded, and life is good.
Thank you for watching. I hope you found it informative. To learn more about this topic, follow the bit.ly link or scan the QR code to download a white paper. To find out more about Weave GitOps, visit our website. We regularly host hands-on workshops. To join in, visit our events page.